Addition of forces. Objective: to study the result of applying more than one force upon an object. In a game of tug-of-war, each team tries to pull the rope towards it. The team which exerts more force on the rope would win the competition. Usually, objects experience more than one force. Sometimes the forces get added, while sometimes they get cancelled. Let us study this in detail by analyzing a situation. John and Steve are trying to shift a table to the other side of the room. First, John starts pushing it by applying a very less force. The table may not move if the applied force is very less, as the table is very heavy. We can represent a force along with its direction using an arrow. Strength of a force is referred to as its magnitude. Length of the arrow that is used to represent force indicates the magnitude of the force. If he increases the magnitude of the force, the table will start moving. He is now able to move the table very slowly, as his force is limited. Now, both John and Steve are pushing it from the same edge in the same direction. The table starts to move easily. How did it become so easy to move now? When both John and Steve pushed in the same direction, the magnitude of their forces combines, resulting in a greater applied force. Hence, it can be inferred that when forces act in the same direction, their magnitudes get added. Suppose Steve and John start pushing the table from the opposite ends, in the direction opposite to each other. If the magnitude of both the applied forces is same, they cancel each other out and the table does not move. If the force applied by one of the boys is greater than the other, the table might move along the direction of greater force. When forces are applied on an object in opposite directions, the magnitude of the net applied force is the difference between the magnitude of individual forces. Let us summarize what we have learnt till now. Forces applied on an object in the same direction add to one another. If the forces act in opposite directions on an object, the net applied force acting on it is the difference between the two forces.